Hello, welcome back to the video for lesson 2.6. In this video, we're going to learn the algebra of functions. So we're going to learn how to add, subtract, multiply, and divide functions. We're also going to learn how to compose functions. I don't want to ruin the surprise. So let's look at how we can add two functions. So if we have functions f and g, we can add the functions together, we can subtract them from one another, we can multiply them and divide them. Look at an example of that. So example 1 says, let f and g be two functions defined as follows. So f is 1 over x plus 2 and g is 2x plus 1. A says find the addition of the two functions f and g. So we're gonna add them, and it just tells us that x is the input. We're not there's no multiplication going on here. It just says I want the sum function, not S-O-M-E, but S-U-M. I want the sum function or the addition of f and g where x is my input. So I'm going to take 1 over x plus 2, and I'm going to add it with 2x plus 1. I'm not going to actually get a common denominator because that's something we're going to do in a later chapter with rational functions, but that's what it would look like. Then B says, find the quotient function of f divided by g when x is the input. So that means I'm going to have f is 1 over x plus 2 all over 2x plus 1. We'll say over 1. And when we divide fractions, we can use the KFC method, which is keep it. So we're going to keep the first fraction as is. We're going to flip it. We're going to flip the second fraction. And then we're going to change the division here to a multiplication. So it's really the function of x 1 over x plus 2 times 2x plus 1. And we could FOIL these. To get a final answer of 1 over 2x squared plus 2x plus 6. You can also do the 4 algebra functions, algebra operations with these functions and evaluate them at some value as well. So now it says let functions f and g be 3x minus 4 and then x squared plus x. And we want to find the difference between f and g, and I want to evaluate it when x equals 2. So I am going to take f, which is 3x minus 4, and I'm going to subtract g. And I'm putting g in a parenthesis because I'm going to have to subtract both terms using the distributive property. So this is 3x minus 4, subtracting x squared, subtracting x. And then we have to remember that they wanted us to evaluate that when x equals 2. So I'm going to put 2 in for x. So we have 3 times 2 minus 4, subtracting 2 squared minus 2. So we have 6 subtracting 4, subtracting 2 squared is 4, subtracting 2. So 6 subtracting, and we've got 4, 4, and 2. So 6 subtracting 10. So this results in a negative 4. Letter B is asking us to take the quotient of f divided by g and then evaluate it at 2. So f divided by g would be 3x minus 4 divided by x squared plus x. The f function divided by the g function. And I'm going to evaluate those at 2. So 3 times 2 minus 4 over 2 squared plus 2. So 6 subtracting 4 over 4 plus 2 simplifies into 2 over 6, or we can reduce that into 1/3. So make sure you're showing me your work on these, how you're arriving at the answer. And the next topic is called composition of functions. Composition of functions is when you have one process and then you use that process in another process. So it's like when they build a car, they actually have to build the motor or the engine in one plant by maybe a separate company, and then they take the engine and then they go and put it together in another plant with the overall production of the car. And so that's where you're using one function inside of another function. So when we say that f is composed with g, where x is the input, it can be written like this. It's f of g of x. And we would say that as f of g of x. And really, if we like to think of things as moving left to right because that's how we learn how to read. So you can actually take this and think of it as from left to right. You're going to take x, and that's going to go into the g of x function first. And then whatever comes out of that g of x function is going to go as the input into the f of x function. So we actually start from the right and we move left. X goes into g, and then that result goes into f. It's called the composition of a function. Let's look at a couple of examples. So example 3 says, we have f of x is x squared minus 2, and g of x is 3x. Evaluate f of g, f composed with g at a -1, and then g composed with f at a -1. When we compose them in the different directions, they end up with possibly two different results. So don't assume that they're going to be the same thing. So the first one, f composed with g at a -1. So that means I'm going to put a -1 into g first. And so I'll have 3 times a -1 is a -3. And then that is going to go into the f function. F of a -3 is a -3 squared minus 2 is 9 minus 2 equals 7. Now we could have composed f with g first and then put a -1 in. And so if I just compose the functions, that means I'm going to put g of x as my input into f. So I've got the outline of f here, something squared minus 2. And g of x, 3x, g of x function is going to go in there. So it's going to be 3x. So 3x squared is 9x squared minus 2. And if we evaluate that at a -1, we'll have 9 times a -1 squared, subtracting 2 is 9 times 1, subtracting 2 is 7. So you can do it either putting in a -1 first or composing them and then evaluating it at a -1. They also wanted us to compose g with f. So g composed with f at a -1. So that means that I'm going to put a -1 into the f function first. So -1 squared minus 2 is 1, subtracting 2 is a -1. And then that means I'm going to put -1 into g, my result here. So 3 times a -1 is a -3. Okay. Example 4 is having us think backwards a little bit. It says find two functions f and g such that when you compose them, they create this composition. And the one that we want to do is, I want it to end up like this. Okay. So I'm going to have a function g of x that's going to go inside the outer shell of f of x. So I'm going to say, let's let f of x be, I'm going to give you two options. Okay. I'm going to say f of x is just going to be the function 3 over x. And then g of x is going to be x squared plus 1. So this is my outer function. And then when I plot x squared plus 1 in for x, it is actually 3 over x squared plus 1. There's many ways to do this. Another option could be, I'm going to have my outer shell be 3 over x plus 1. And then my g of x is just x squared. So x squared just replaces x, and then I have 3 over x squared plus 1. So there's a couple ways I could break this apart. You're going to get to try these on your own in the homework. I always look forward to see what students come up with. The last example that I have for you today is example 5. The number of copies of a popular mystery writer's newest release sold at a local bookstore during each month after its release is given by this. This is the total number of copies. So this is copies sold copies, and then this is the month during each month after. So each month after its release. The price of the book during each month after its release is given by this. So this is the price, and then X is the month. So notice that they have to have the same input for this composition to work. So it says find n times p and evaluate that at 3 and interpret your results. So n times p. So n times p. So let's do that. So we've got a negative 5x plus 100. So this is the number of copies sold times the price. That's going to be interesting. So number of copies sold times the price per copy. Okay. So just in words, number of copies sold, which is the first function, times the price per copy is going to give us the total revenue. Total sales or total revenue, not necessarily the total profit. Profit is what you made over and above your cost, but this would just be total sales. Okay, so negative 5x plus 100 multiplied by a negative 1.5x, oops, plus 30. Okay, so I'm going to multiply a negative 5 times a negative 1.5 is going to give us a positive 7.5x squared. I've got to use FOIL here. And then a negative 5x times 30 is a negative 150x. And then 100 times a negative 1.5 is a negative 150x. And then 100 times 30 is a positive 3,000. So let's get this summed up. 7.5x squared minus 300x plus 3,000. And then evaluate when X equals 3. Let's remind yourself what X equals 3 mean. X is the month after its release. Number of months after book release. Okay. So that means 7.5 times 3 squared minus 300 times 3 plus 3,000. So 7.5 times 9 minus 900 plus 3,000. I'm going to be smart and do this on my calculator. So 7.5 times 9 is 67.5. Minus 900 plus 3,000. And this is going to be dollars. And that comes out to $2,167.50. And it says, interpret your results. So what does that mean? The total sales is $2,167.50. 3 months after the book is released. So this is where we might use this in the real world. Catch me back for another video.